Tonight we have a really special behind the scenes edition, and this is going to be about the mysterious center channel and about surround sound. So everyone has heard a lot about surround, and of course we are all fascinated that you can get 3D sound in your living room, and you can enjoy movie theater sound in your living room, and you can hear sounds around you, behind you, and you can almost feel as if the actors were in your room playing out the movie. Do you? Wow. Actually, this was my expectation when I grew up, and when surround came out, and you could buy the first surround systems, and you read all, I mean, I also read all the fancy spiel on the magazines, and and you heard it, and well, it was better than watching a TV set, like a CRT TV set, but it was noticeably better, and a step up in the experience, but really far away still from a real movie theater experience. And when I heard later on a real two-channel audiophile properly set up system, that was like a huge facepalm moment. And then I realized that this surround thing is just screwing around in the dark, really. So it's not something serious. It's a toy at best, and I was really baffled because I grew up with computers, and was very mathematical minded, very digital minded, and when I got faced with the reality of two channels and vacuum tubes, I just had to make a reality check and then go on a journey to search what's behind these things. So now I'm going to reveal to you the center channel came up. It was created because of projection screens and movie theaters. So initially, uh, the projection rooms are really gigantic. Even the small rooms have 34 feet wide projection screens. So that's 10 meters wide. So if you are going to produce an image that creates a surround image coming from the width of the screen, you are going to have to place the speakers 10 meters away from each other. And when that happens, and this then in the center, if you are sitting in the first row, you will not get a good center image, because by that time the sound coming from the two speakers will not have enough time to interfere with each other to create a three-dimensional effect, and you will just hear the left speaker and the right speaker just talking to you. So that's why they need a third channel, especially when you look at the bigger rooms. Like a normal room is 14 meters, has a 14-meter screen, and IMAXs can go up to, the biggest is 35 meters wide screen. So if you have a left channel and a right channel and nothing in the middle, then it would be a truly bizarre and absurd experience. So because of we have the theater screens, we really need a third channel in the middle. And I'm trying to get some pointer here because this is going to be really difficult without drawing. So here I got for you an actual theater layout, a movie theater layout, and we see here we have the three speakers, the center channel, left, right channel. This is the screen. There was a curtain before that they could draw as a nice touch in the old days, and the seats. And you see there they are arranged to three banks. There's like a center, left, and right. And as you see, each of the speaker is facing one of these big chunks of seat. And you can see that if you are in the center area, then you will hear an equal amount of the left and the right speakers. But if you are not in the center but somewhere around the close to the wall, then you are basically getting only one speaker mostly. And if we did not have this center channel, then we would have you can see like right here you are super close to this channel, but you are the distance between you and the other speaker is about 3 times as much as here. And you know that with the distance, just by doubling the distance, you get a 6 dB loss in the efficiency. So it means that right here you get a 9 dB quieter sound from this channel compared to that channel. But that was the case. That would be the case if they were omnidirectional speakers. However, they have directionality, and because of the directionality, you get even less of the sound in that seat from this channel. So there's much more lost than just those 9 dBs. For the high frequencies, your losses will be well over 20 dB or even more. So that's why they came up with the center channel, that if you are sitting right here using the center channel, you still get some effect from of spatiality that mimics this speaker. So actually the third speaker, even in a movie theater, was created as a compromise to deal with the massive size of the theater. And let's just have an idea about what's going on. So like the distance between these two speakers is 14 meters. That's gigantic. And the center channel, so the distance between the centers of these speakers is 7 meters. And if we were to make an equilateral triangle, like 14 meters, this is 14 meters, that's 14 meters, then the optimal best sounding spot is right there where those two blue arrows meet. And you see, if you are sitting there and you had only 2 channels in the cinema, then you would be able to enjoy a good stereophonic sound, a perfect 3D surround image. However, if you move more forward, then it's not enough time for these sound waves to merge and create that spatial 3D-dimensional information. So if you are coming more forward, then you are not at the optimal spot, and that's where this third channel helps a little bit, because if you are moving in ahead of the point of this triangle, then you will start to hear more and more that the sound is separating to 2 sides, and you will hear from left and right separately instead of a 3-dimensional all-encompassing image. So that all-encompassing image starts at the tip of the triangle and goes more back, and in the front we can cover it with the third channel. And what else does this third channel do? And as you see, let's just go into the scenario of the on-axis response of the speakers and off-axis response. Sometimes you can see this as parameters, and when people do measurements they talk about on-axis or off-axis, and why does that count? I show you, this is what counts, and this is why it does matter. So you see, when they specify parameters of a speaker like 20 or so 20K, they mean it for the on-axis response. It means that where you are pointing your speakers towards, that's your on-axis response. If you are sitting there, then that's what you are getting. If it's pointing away from you, then it means that the majority of the output of that speaker will go by you. so you will be not hearing it. And the higher we go in frequency, the more directional the sound gets. So as we are sitting off axis, like these fine folks, for example, here and here, they are hearing less and less of the high frequency information. And when manufacturers show their stuff, then they talk about the 30-degree dispersion. Like, let's see, for the center channel here, this is the green is the on-axis response, and the blue is the 30-degree off-axis. So it means that if you are sitting 30 degrees off the center of your speaker, where your speaker is pointing, then you are getting a specific amount of information. And usually speakers are built in a way that down to 30 degrees they still have considerable output. And here this shows the red scenario, the 60 degrees range, which means that you are 60 degrees off from that channel. So basically, if you are sitting right here on that in that chair, that's just about the 60 degrees off position. That usually means that at 60 degrees, unless you are listening to omnidirectional speakers, so you are listening to regular bass reflex or horn speakers, at 60 degrees you are getting minimal high frequency response, like severe roll off. And if you want to have a spatial surround experience, you need the high frequency information. So that's why the center channel is there, because for these fine gentlemen here, from the center channel you get, like, even at the third seat right there, you already are within the 30-degree off axis of the center channel. So that's why you notice when you go into the movie theater, you sit in the first rows, then you notice that the first couple chairs, first 2 or 3, depending on how big the room is, it's really those are the worst sounding chairs in the room, because you get a really loud on-axis response from the speaker that's in front of you, but even from the center channel, so the other side information, you are getting even less than the 30 degrees off axis response. It means that you are not hearing that nice surround 3D sound around you. And the reason is not because there are not enough additional speakers on the side walls, but it's because you are at a spot where these main speakers do not provide enough coverage. And when you sit, let's see, that's something really different. So I'm going to continue my previous thought on the next slide. So right now I'm just stopping my train of thought with a demonstration about these on-axis and off-axis response. So here I'm showing to you this might be possibly the best tweeter that we have. It's a focal Utopia beryllium tweeter, and that's pretty much the best we as mankind could come up with in respective to a high frequency driver. And you look at the frequency response, this is the on-axis figure. So you see, like, above what's this, like 8 kilohertz, 7-8 kilohertz, up to that point there's no difference between on-axis, off-axis. So if we were to place this in a movie theater or into a home theater system, then if you are sitting 30 degrees off to the speakers, or even 60 degrees off, actually it doesn't show the 60 degrees, this just shows on-axis and 30 degrees. So up to 8 kilohertz, if you are 30 degrees off, then you still have up to 8 kilohertz sound. It's unchanged. So in your couch, you can sit in the center, you can slide to the end of your couch, up to 8 kilohertz you will be hearing the same. But higher than that, you will see that if you are not at the sweet spot, so the tweeters are not firing at you, but you are moving to the side, then you are getting this roll off, you see? And this roll off at 15 kilohertz, it's at minus 6 dB, and where is that? It's around here, and at 20 kilohertz, it's minus 10 dBs. So if you are at the edge of your couch, then from that speaker, which is 30 degrees off, so that's where you are further away from, you are getting much quieter output because you are further away from that driver. But in addition to that, you are also getting extra minus 10 dB cut because it's on your off axis. So because you get off axis from the output. So that's why it's a really big thing, that where you are sitting in relationship to the speaker's output. And the previous figure, that was the best off-axis response that we can get, really. Eventually, if you use horns are, I would say, they are the ones that can keep the best off-axis response up to a reasonable width. So up to like 45 degrees, if you have like these speakers, like the Altec voice of the theater speakers, up to 45 degrees they work pretty better than compared to if we had just regular bass reflex cabinets. They are not as good with their dispersion characteristics into a big room as these horn speakers are. So no wonder they came up with the Altec voice of the theater system, because it's really optimized for a theater, for this scenario. And it's because the theater is so big, the size is so huge, and there are seats which are really far away from the center. That's why we need 3 channels. But if our situation would be smaller, and if we had only 2 speakers, and the people were not sitting that packed, just you would have like around here a group of folks, like you had a sofa here and 5-6 people sitting on it, then those 2 speakers would provide a perfect 3-dimensional sound for you. And actually in the movie theater the same thing happens, because if you happen to sit around here, then essentially what you hear, 90% of the output is coming from these 2 speakers. So in the movie theater you are hearing only 3 channels if you are sitting at the center. If you are sitting somewhere here or somewhere there, you are basically hearing these 2 speakers and a very, very little of the one that's furthest away from you. So if they were to turn off that channel and you are sitting here, you wouldn't even notice that speaker went out. Now let's just put as a comparison like a big living room, or I would say like an average size living room, like a 4 meter by 6 meter. That's not that big. It depends where you live. In Hawaii, that's considered a very big living room, because here everything is much more packed. There's not so much space as in Texas. So here, if you just put your 2 speakers here, there's this really tiny distance between the 2 of them, and by the time the sound reaches to you, it does have your couches here. It has enough time to merge into a 3-dimensional surround experience. So if you were to place a 3rd one in the center, that would not do any good to the sound, really. So now, why did we keep on this tradition of moving the third channel down into the stereo? Because just think about it, even when stereo came out, in the movie theaters they implemented it as a 3 channel, but for homes they mixed it down for 2 channels. So all of the earliest RCAs are 2 channels and not 3. And that was not just partially because when people changed over from mono to stereo, they had to basically double their equipment, and if for 3 channel they wouldn't have needed to triple it. But between doubling and tripling there's not that much of a difference. The real difference is that in a living room setting, 3 versus 2 doesn't really give any advantage. So as we went from cinema to the living room, speakers size shrank. So speakers got smaller and smaller, and this tiny size heavily compromised the frequency response, especially the mid bass and the bass. So and if you do not have a nice mid bass response and deep bass, then you feel your mind will interpret it as if it has shrunk. So that's why small bookshelf speakers present a small image, a small stereo image, because they cannot carry that mid bass and deep bass information that will signal your brain that you are surrounded, you are in a space that's filled up with music. And the other thing that contributed to the problems was that we started using like cheaper and worse mass producible materials for speaker cabinets. Everyone knows, every speaker designer knows that to have a good sounding speaker you need a high quality cabinet, and basically that means instrument grade wood, because speakers are music instrument. They reproduce music just like a violin does, just like a guitar does, just like a cello does. And no one in their right mind would make a cello out of cardboard or plastic. But that's what happened to audio loudspeakers, because that was cheaper to make and easier to make a long production with it. Try to make 50,000 loudspeakers with cabinets the quality of a violin. It's an impossible undertaking. The costs would be like tremendous, and the amount of work needed to prepare them, that's not feasible for such big quantities. And that was the production sizes that we needed for making loudspeakers for families, to have music in everyone's living room and bedroom and wherever, office. So as we went for these ugly materials, these materials give their coloration to the sound, and they smear time information, they smear harmonic content, and all of that millisecond. So for example, if you have like a plastic cabinet, it stores energy and radiates it back like a couple milliseconds later. The same thing goes with cheap wooden cabinets, which are like particle boards. And this delay causes the loss of spatial information. So when you have 1 or 2 speakers and you listen to them, and you just hear sound coming from 2 boxes, it's not because you need more than 2 channels to reproduce sound in space. It's because the sound coming from those 2 boxes is getting colored by those boxes to such a degree that all the spatial information is lost. In addition to these cabinet problems, uh, there was the huge problem of cheap and early solid state electronics with high negative feedback. So that extreme amounts of negative feedback also destroy spatial information, and 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 early solid state gear had a really bad high frequency distortions that they produced, and their clipping was really terrible, affected the high frequencies, and this resulted in additional loss of the spatial information. Cheap cables, they do the same thing. They have a high frequency smear, so your high frequency signal, whatever is left, is even more cut. And in addition, because of these small cabinet sizes, as the sound waves wrap around the cabinet, there's a buffer step loss, and then you have these narrow buffers. You have serious anomalies around 1 kilohertz because of that buffer step loss, and from 1 to 3 kilohertz, that's absolutely necessary for spatial coordination. So if we mess up that frequency range, then we severely compromise the 3D effect. And so Sony started to call this as wall of sound. So the sound, it was not surround anymore, but it just went back into the speakers. So and the reason why the sound receded back into those boxes and became just a wall was because of these problems. And one more thing that made this issue much worse, and where Sony perfected the wall of sound, is the use of a large number of drivers. Because the more drivers have, the more complex your crossover, the more phase problems you can potentially introduce to the sound, and the phase issues also remove spatial information. And by playing around with the phase information, the Sony was able to make this wall of sound that removed any kind of spatial sense from music. And this type of technology was what spread into mass consumption from like 70s, 80s on, and still we have this sort of technology today. The only change is now we have Class D amplifiers, high excursion drivers, DSP, so we get the exact same thing, just much louder than before. So because we have lost 3D sound, that's why people wanted to bring back that movie theater feel in your living room as well. And they realized that basically the only way to do that would be to bring those movie theater speakers into your living room, and then you get the same amazing 3D sound that you have in a movie theater. But that was not a viable option. The people, save up their space in the living room for their kids, for like chair and tables, coffee table, whatnot. They not necessarily want to empty half of their home just for two gigantic speaker cabinets. So that thus came the theory or the practice of tiny wieners and the woofer. And this is the most extreme example of it, but as you know, there's a lot of surround applications when you have like two channels which are relatively big, and the surround channels and center channels are much smaller, and they can be shrunk down to the Wiener size category. But even if you have a floor standard, if it's still that narrow buffer design, you still have that narrow sound. Even though with proper high quality two-way speakers, you can already give back the spatial feel into your living room. So there's no problem with that. And the engineers who came up with Dolby Surround knew it. that if you have a properly set up two-way system, two speakers. I mean, under two-way I mean two channel, not two drivers. So if you have like a properly set up two channel, then you have a 3D image, but for that you need to set up properly. So you need to place your speakers at the optimal position, your seat has to be at the optimal position, and when you install this Weenie Mini system, then you can just, hang them in the corners, pull them back to the wall, so they won't interfere with your family business. Kids can run about, they won't knock them over because they're hung somewhere up in the ceiling, or maybe not the ceiling, but away from the reach of those pesky kids. So anyway, the consideration was that to come up with a compromise that works for an average family who doesn't really care about what stuff you put in there. Ask your neighbor what's the brand of your surround. If you ask the spouse or the kids, they probably don't know. We just have something. Here's the remote. You turn it on here. What more do I need to know? Nothing. It's just an appliance. So the idea was behind this was to come up with something that is in the appliance category, where you don't need to apply any thought whatsoever after you purchased it. You read the instructions, you set it up, forget it ever existed, just push the button. So eventually, how they came up with so many wieners. In the beginning, they thought that we just add the center channel, like a third wiener in the middle, but we realized that these guys can only create that wall of sound. If we add the third channel, that doesn't do any difference. So that's why we started putting more wieners behind our backs, because then there's sound coming from behind you, and that gives you the illusion, oh, something is happening. However, it doesn't really work well, because, for example, when they shoot the movies, they do not shoot it so that the surround is designed to be the size of your living room, but it's designed to be the size of a movie theater room. And when you downscale it into a living room, it just doesn't do it. And also in the movie theater, you have high quality JBL and Altec speakers, and they are capable of reproducing 3D sound, and these wieners are not capable of reproducing 3D sound. So the idea that you place loudspeakers around you, it's not enough to create a surround experience. Those speakers that you are placing around you have to be of that quality that they can supply spatial information. And these tiny wieners are not qualified for that, I'm sorry to say. So basically it's a really nice effort for reproducing a 3D sound in your living room, and at a fantastic price, I would say, and you get what you pay for. So it's a really nice option, but it's not a movie theater sound, and it's not the 3D sound that you get from a properly set up 2-channel system. So now to close things up, I have for everyone a little quiz in biology, and I will follow it up with a lesson in biology. So that sometimes it's better if we learn a little biology before we go deep into engineering, because we can find out what are the dead ends. So okay, that's it. So how many ears do we have? That is a human being. How many ears? Answer A. Choice A. 5 plus 1. Choice B. 7 plus 1. Choice C. 16 plus 2. Choice D. 2. Last time I counted, we have 1, 2 ears. And that's not just for Julius Caesar, everyone has 2 ears. Unless you have the shaving accident. But even then, you still have 2 ears, just maybe missing earlobes. So the issue with that is that the brain calculates 3D location of the origin of a sound through ASP. ASP means not DSP, ASP means analog sound processing, which means that the brain calculates it using our own neurological circuits to calculate where the sound started based on the frequency and phase and level information of the sound. And that's because our ears, they cannot sense direction. One ear doesn't sense any direction at all. The ear senses only frequency content and loudness, how loud those frequencies were. If the same source is coming from here or there, the ear cannot tell it. So the neurons inside your hearing canal, they just transfer and translate frequency and loudness information. And because we have 2 ears separated by the head, it means that because of the distance between the 2 ears, that corresponds to a 500 Hertz wavelength. And because of that 500 Hertz difference between the 2 ears, so your face acts as a shield between the 2 ears, this will help for us to pinpoint the source of the sound, because as the sound waves will travel to your ear, it hits this ear in a certain way, but to hit your other ear, it has to pass through your head, which means that the sound waves will have to bounce and diffract and refract from your head, and then travel to somewhere in the room and then bounce back from the room. And then from that bounce back time, your brain can calculate if the time was really short, then that the source was very close. If the lag was really long, then it happened really far away. So our brain processes the sound, and because we have 2 sources, the brain is comparing the information coming from these sources. And because of the difference, the distance between these 2 ears, basically the lowest spatial information can be gathered from 500 Hertz. So if the sound is higher than 500, let's say a kilohertz, 2 kilohertz, 10 kilohertz, the higher it is, the more precisely we can tell where it's coming from, because there's more data to calculate from where it exactly happened. And as it gets close to 500 Hertz, then we get into trouble. But down to 80 Hertz, we can still roughly say about which direction that sound is coming from, but we cannot pinpoint it. We can pinpoint above 500, we can sense any directionality above 80 Hertz, and below 80 Hertz you just feel the sound and you cannot tell where it's coming from. So basically, this means that because of this fact that we use 2 detectors, basically we have 2 microphones working for us. If you have 2 sources talking to these 2 microphones, you can create perfect 3-dimensional full surround immersion. If you add a 3rd source or a 4th, 5th, 6th, it's just going to mess up what those 2 sources produce, and it's going to make imaging worse. So this is just a mathematical and a biological fact that as you increase the number of speakers beyond 2, you are decreasing the ability to create a good spatial image. And this hinges on the fact that those two sources are perfect sources. And the higher quality loudspeakers they are, the more your brain can recreate a three-dimensional scenario from it. And then we need only 2 speakers. But as you drop down the quality, the build quality of those speakers and the reproduction equipment, then you will need those additional speakers, because they are not able to create three-dimensional sound anymore, just a wall of sound. And that's when you need several walls of sound to create an illusion that you are immersed. So thank you for listening. I hope this was a useful little demo for everyone, and thank you. Please like and subscribe.